Some of the students complain that physics is a difficult subject, difficult to study, difficult to follow, difficult to understand and difficult to score. If you are also one among them, I hope I can help you to enjoy physics and score an A+, if not a centum. This is Lex Nova channel and I am Jason sir, your physics teacher. In our previous lesson, we have seen something called electric flux. If you have not seen that video, please see that video and come back. I am giving the link of that video in the description box. It will be easy for you. In that video, what we studied is electric flux. Electric flux is the number of electric field lines passing through an area, we say. Now, is that a useful thing? You are counting something that is totally imaginary. Now, the fact is, it leads to a very fundamental idea of physics which is used in electrical engineering very often. We are going to study that today. And you know, this is one of the most important examination questions also. And let's start today's topic. Today, you imagine a football. Okay. We need a football. You know, football we imagining because it is a closed surface. Okay. And just imagine a charge inside, somewhere inside. Okay, let it be at the center. A charge of say 10 microcoulomb. And we have already seen that from this charge, positive charge, electric field lines are drawn out, radially out. So, if you imagine this surface and the flux through that, the electric field lines will be going out. Correct, no? So, I am drawing few lines like this. Few lines I am drawing. We say through this football you have an outflux. Outflux. Why we say outflux? Because the electric field lines or the flux lines are going out. I hope you understood that. And if you increase the number of charge, say from 10 microcoulomb to 20 microcoulomb, naturally the outflux also increases. So you can say as the more the charge inside the football, more is the outflux. Correct? Instead of positive charge, if you have a negative charge, what change will be there? Imagine, redraw that into your notebook. What change will be there? Instead of positive charge, if you have a negative charge, the change will be the arrows will be pointing in. And instead of outflux, you will get an influx. Correct? And if you increase that negative charge, you can say the influx also increases. Correct? No? And imagine this scenario. Along with this positive charge, imagine minus 2 microcoulomb negative charge also. That is, this time you have positive charge and also negative charge. This positive charge produces outflux and this negative charge produces influx. And in this case, you can tell me that here you will have an outflux that is equal to the outflux of 8 microcoulomb. Correct, no? How is that 8 microcoulomb coming? This difference, the sum, we take the sum. Correct? So, if you have both positive and negative charges, you will have both outflux and influx. So, you can write it this way. The total flux is proportional to, why we write total flux? Because in such cases where positive and negative charges are there, you will have both outflux and influx. So, for getting the total flux, you write the total flux. Total flux is proportional to the, what is this? Total. If you have a, in this case it is plus 10 plus minus 2, here you will write plus 8 microcoulomb. So, for indicating the total you are writing this sigma. So, I can write total flux is proportional to the total charge. And just like in any other physics situation, the next logical step is total flux is equal to, you will have a constant coming here. The constant we have these days is epsilon 0, 1 by epsilon 0 times sigma q. So total flux is equal to 1 by epsilon 0 times sigma q. Sigma q means total charge. So you can also write this equation like this. Total flux is equal to 1 by epsilon 0 times the total charge. This is how we write the same idea in words. You know, this idea was first derived by Carl Friedrich Gauss, and this is known as the Gauss theorem. What is that? Gauss theorem. This probably is the most important in the sense exam sensitive and also for higher studies. This is the most important topic of the entire +2, the total electric flux or total flux we usually write as 1 by epsilon 0 times the total charge. You understand all these things. In case if you need, rewind it and see it once again, but this equation is very important for us. Total flux is equal to 1 by epsilon 0 times the total charge. So I have a fresh board again, and I am going to write the Gauss theorem equation here. That is total flux is equal to 1 by epsilon 0 times the total charge. Okay, you also write it again. Now we will revisit the earlier situation. You have a football. Okay, just imagine that you have a +1 microcoulomb charge inside. We will apply Gauss theorem in this particular situation. So remember, the total flux is the electric flux through this football, and the total charge is the charge that is inside. So I am writing, substituting in this, total flux is 1 by epsilon 0, 1 by epsilon 0 you know is 8.85 into 10 raised to minus 12 into total flux is total charge is 1 into 10 raised to minus 6 microcoulomb converted. Okay, this is equal to, do the calculation and write the answer. See, for ease of calculation I take this to be 10, 8.85 I take it as 10. So it is 1 by 10 is 0.1, okay, into 10 raised to plus 6, that is 1 into 10 raised to 5. If you go for the logical unit for total flux, you will get so many lines. But remember, the unit of electric flux is Newton. Tell me, what was that unit? Newton meter square per coulomb. That was the unit. But this is the idea we use. So what we get is, through this football, if you keep a 1 microcoulomb charge inside, 10 raised to 5 lines are there. 10 raised to 5 is 1 lakh. Simple. You have 1 lakh electric field lines coming out of a football if you keep a charge of 1 microcoulomb inside. That is an outflux. So instead of positive charge, if you keep a negative charge, this will be an influx. Now the question is, you have 1 lakh electric field lines coming out. Is that a useful entity? Can anyone count it? Is it a real thing? How useful it is? You may doubt, no? The thing is, you just understand it like this. For our physical understanding, this idea is good. Now, another thing is, instead of 1 microcoulomb, if you have say 10 microcoulomb, how many lines will be passing there? This is 1 lakh, then it will be 10 lakh. Okay. And instead of, if I take minus 1 microcoulomb also inside, what will be the total flux? The total flux will be 0. So once in an exam this question came. Inside a football you have a dipole. What is the total electric flux? What is the total electric flux? In a dipole, the charges are equal and opposite, the total electric flux will be 0. And for better understanding, you just imagine a charge outside here. So far we were discussing charges only inside the football. Now imagine a charge outside here. So the inside charge, I am correcting this inside charge to be plus 1 microcoulomb, and we imagine there are 1 lakh lines coming out, or 1 lakh is the total electric flux. I am imagining another charge, say some 2 microcoulomb plus, means electric field lines will be coming out like this. So naturally, few of the electric field lines produced by this charge will be passing through this also, this football also. Then you see, if just imagine some 10,000 lines are passing, just imagine 10,000 lines are passing. That means in this equation, should we include this charge? It's very important. Remember, this 2 microcoulomb charge produces an influx of 10,000 lines here, and it gives an outflux also there. That means in the total flux calculation, you can comfortably include this charge, but it produces an influx and an outflux, there is no change. But remember, on the right side, in case of total charge, you should not include this, because this doesn't produce any net flux in this football. I hope you understood. So in this Gauss theorem equation, on the left side, when you calculate the total flux, you are actually calculating the total flux due to charges inside and also the charges outside. But on the right side, you include only those charges that are inside. I hope you understood, because outside charges will not produce any net flux here. So when you go for a statement of the Gauss theorem, this is how we state it. And remember, whenever you are stating laws or theorems in physics, especially in the exam, it should be verbatim correct, means not even a word should go wrong. So this is how we write Gauss theorem as a theorem in the exam. You may write it. The total electric flux through a closed surface in free space is 1 by epsilon 0 times the net charge enclosed. Have you finished writing? I repeat that. The total electric flux through a closed surface in free space is 1 by epsilon 0 times the net charge or the total charge enclosed by the surface. Remember, every word in Gauss theorem is important. Every word, I must say every word. You study that first, by heart it, then listen to me. Okay? The theorem says like this: the total flux. We are interested in total flux, or the word total should not be missing there, because it can include, or it means the influx as well as the outflux. So the total flux, precisely you must say total electric flux. The total electric flux through a closed surface. The word through must be there, because then only the idea of going into and out comes in. Correct, no? The total electric flux through a closed surface. The surface must be closed. Then only you can distinguish between a charge inside and outside. And of course, you should, when you are considering charges of this kind, discrete charges, charge should not be residing on the surface. Then you cannot say which is inside or which is outside. So it should be like this, no? The total electric flux through a closed surface in free space. In free space is really important, because then only 1 by epsilon 0 comes in. If you have any other medium, instead of epsilon 0, the epsilon of that medium you should write. Correct? Then you should specifically say in vacuum or in air. So the total electric flux through a closed surface in free space is 1 by epsilon 0 times the total charge or net charge. You have to again write total here, The reason is you may have positive charges as well as negative charges. The total charge enclosed by the surface, you must write enclosed, because the charges inside only are considered, outside charges are not considered. So verbatim you must study, by heart it, Gauss theorem, such an important thing. Now for understanding Gauss theorem better, this is how we understand something better. We take more and more examples. You just imagine a situation like this here. You have in air, say some 10 microcoulomb charge here, 2 microcoulomb positive charge here, 5 microcoulomb negative charge here, 8 microcoulomb charge, of course a minus charge here, and 3 microcoulomb say negative charge here. You have some 5 charges like this. Now how to apply Gauss theorem? That's what we are going to talk. Now copy this into your notebook. And when you are applying Gauss theorem, earlier we were talking about a very regular sized football shape. Now the shape need not be regular like that. Just imagine, I am going to imagine a surface through which the total flux I am going to find out. Say this is the surface I am imagining. Very weird imagination, no? Correct? See, this is a surface I am imagining. I am going to apply Gauss theorem. So total flux is equal to 1 by epsilon 0 into total charge. I write. Okay, you write it. Total flux through this surface I am going to find out. Now how to find it out? You have to find 1 by epsilon 0 you substitute into total charge. Here how much is the total charge? Should I add up all the 5 charges here? Is it like that? No. You need to add up only the charges inside this surface. Such surfaces over which we apply Gauss theorem is called Gaussian surface. So here this is a very peculiarly shaped Gaussian surface. The charge inside here is plus 10 plus minus 8 microcoulomb. So the charge will be, the total charge will be plus 2. So excuse me, you can say the total flux through this will be, you calculate, you will get the answer exactly. Earlier we said no, 1 microcoulomb produces 1 lakh. Then it will be an outflux of 2 lakh lines. I hope you understood. Now does it mean that these charges, what about these charges? This charge is producing electric flux through this. Why you are not calculating? We have calculated. This plus charge is actually giving an influx and an equal outflux. So it is actually included in this calculation. As this charge is outside, it cannot produce any net flux or total flux. So we are not included here. I hope you understood that. Now I am going to imagine another surface. Say like this. Okay, let's remove this surface. Now I am taking another surface. Okay, what is the flux through this peculiarly shaped surface? So the total flux will be, what are the 3 charges? What are the charges we should add up? Minus, incidentally only minus charges. So you will have the total is 16. So that is an influx, correct? So the total flux will be, total influx will be 1 by epsilon 0 times into total charge. In the total charge you include charge 1, 2, 3. Okay. Remember again, on the left side the total flux is the flux through all the charges, but only inside charges are taken for this Gaussian surface, because only that charge produces a net flux. And whenever you are imagining Gauss theorem, you should imagine a closed surface first. When you are applying on discrete charges, the Gaussian surface should not be drawn over a charge. That also you should keep in mind. Just imagine you have a surface, a spherical surface. At the center you are keeping say some 2 microcoulomb charge, 2 microcoulomb charge. And a question once came in the exam. Actually, we are discussing different exam questions. What will be the flux through the upper hemisphere? What is the electric flux through this upper hemisphere? Remember, the charge is at the center. If the charge is at the center, it produces a uniform, not uniform, it produces a symmetric, that's the word we should use, not uniform, a symmetric flux to all the sides. So the total flux will be equal to 1 by epsilon 0 into, let's take instead of 2 microcoulomb, let's take a charge q, so that it can be any charge, okay. You can substitute whatever value you are getting in the exam. So this much of flux will be there. If it is a positive charge, it is outflux. If it's a negative charge, it's an influx. Okay. Now the question is, how much flux is there through the upper hemisphere? The answer is half of this, because it is a kind of symmetric situation. So into 1 by 2. So I hope you understood that. Okay. Now whenever we are discussing examples like this, if you have any doubt, what you can do is you WhatsApp me in the number, or you can even join my WhatsApp group for helping students. The link is given in the description box. Feel free to join and ask me questions, no problem. I am happy to answer your questions. So that's it. So if it is a negative charge, it's an influx. And remember, if the charge is not at the center, the situation is not symmetrical, you cannot use this idea. Remember that. And once another question came, you have a cube, like I am using my chalk box here. Okay, you have a cube, a situation like you have a cube. And at the center of the cube, you have a charge q. The charge q is there at the center of this cube. How much flux is through one surface was the question. Remember, again the charge is held at the center, so naturally it's a symmetric situation. So the total flux will be equal to q divided by epsilon 0 using Gauss theorem. So through one surface, how much field will be there? How much flux will be there? We can easily find it out by finding how many sides are there for this cube. 4, 5, 6, total 6 sides. So all the 6 sides put together will have this much of flux. So what will be the flux through one side? It will be 1 by 6th of this. I hope you understood. Now, whenever we are in the class, I used to say, nature will tell you, will this question come in the exam like that. Now when I am shooting now, it's quite sunny now, and I think this question can be expected in the next exam. How is that? And another important question. Now these questions we are discussing for you to understand this idea better. Just imagine you have a charge q at the corner of our class. At the corner of our class, how much electric flux is coming to our class from that charge? Imagine. The situation is the charge is at the corner there. This corner is shared by the other class, that class, and that class also. So this corner is shared by 4 classes in this floor and another 4 classes in the lower floor. So this corner is shared by 8 classes. The total electric flux is q by epsilon 0. So the flux that is coming to one class will be how much? 1 by 8th of q by epsilon 0. Is that right? We arrived at Gauss theorem logically. Sometimes they ask you to prove the Gauss theorem in the exam. This is how we prove the Gauss theorem. That's also easy. You imagine a point charge, say q here, and another point here, which is say r distance away. The electric field here, E is equal to, tell me the equation. E is equal to, you must be studying all the equations by heart. Then only you can write it quickly. Okay. E is equal to 1 by 4 pi epsilon 0 into Q by R square. Now what you have to do is, for proving Gauss theorem, you have to imagine a surface. So I imagine this surface, a spherical surface with the radius r with the charge at the center. So in the exam, how do we write? Imagine a spherical Gaussian surface concentric with the charge with radius r. Study that. No, the thing is, you need not study these things by heart. The thing is, if you remember such things are important, you will tend to notice such things and tend to write it correctly in the exam. That's it. Now I imagine a smaller area here, a small area, say the area S. The electric field is in this direction. As you studied in the previous class, the area vector also is in that direction. So the angle between E and S is 0. So the flux through this small surface, is equal to, now the equation of flux is E dot S. This is equal to E into S into cos 0. Cos 0 is 1. So the flux is Es. Now I have to find the total flux through this entire area. So I am writing that. So you need to write only like this in the exam also. So the total flux is equal to, you have to find the total here. So it is E. E is a constant which is not changing. So that is E into total area. This is actually an approximation. This way of finding total flux can be questioned, but in the exam it's okay. Don't worry about that. The thing is, you have to be little more mathematical in this area. For the time being, we are not considering that. Leave it. So this is equal to, I am substituting E. E is 1 by 4 pi epsilon 0 into Q divided by R square. And the total area of this sphere is 4 pi R square. So cancelling, you have to do it. You will get total flux is equal to Q divided by epsilon 0. Only Q is remaining there, Q by epsilon 0 you will get. This is how you cancel it. Okay, so that stands proved. Now the thing is, this can be done in a more rigorous mathematical way. We are not bothered of it. Now including too much of mathematics makes physics little dull. So don't worry, this is okay. And another thing you have to remember is, see, I took R random. You can take any value. Even if you take a larger radius sphere, the total flux is the same. Remember that. Last year during the study time, I got a WhatsApp message from Acube. I am going to show you that.
സാറ് ഓരോ ചാപ്റ്ററിലും തരുന്ന ക്വസ്റ്റ്യൻസ് പഠിക്കുന്നുണ്ട്. പിന്നെ ഈ റിവിഷൻ വരുമ്പോൾ ശ്രദ്ധിക്കാൻ വേണ്ടി ഏറ്റവും പ്രധാനപ്പെട്ട കുറച്ച് ടോപ്പിക്സ് പറഞ്ഞു തരുമോ?
And I can guarantee you the topic Gauss theorem is very much important, and no exam passes without touching Gauss theorem. Remember, Gauss theorem, this is the equation you can write. Now the total flux is actually a total of E dot S. E dot S is equal to 1 by epsilon 0 into sigma q. We have done many exercises or many questions to understand this equation. So what is the use of this equation is, using Gauss theorem you can comfortably calculate the electric field in many situations. So that is the use of Gauss theorem, and those uses are also important for the exam. We have 3 important applications that we will be studying in the next video.